Hello friends, welcome to the video solutions of mock number 2, the QA section for the year 2023. Now friends, in this video, I'll be giving you the appropriate solutions for each and every question. It might be possible that I'll be giving you more than one way of solving the same question. Now, in that case, I'll be explaining the conventional method as well, which will be understood by all the students as per the written solutions which are given. Also, in some cases, I may end up giving you any of the alternate solution, which might be an unconventional way of solving that question. That will save plenty of your time. All right. So make sure that while when you are done with the mock number 2, at the time of analysis, you go through the solutions of each and every question and compare the solution provided by us with the solution that you have actually used at the time of taking this mock paper. Now, this particular exercise will help you in devising some of the proper solutions, and ultimately what will happen is you will be able to understand what are the most efficient ways of solving these questions, and in that case you will be able to save plenty of time in the actual examination, and that will result in a better percentile score for all of you. All right, so let us go towards the question number 1 of the QA section of mock cat 2 for the year 2023. Question number 1 now. Now, question number 1 is asking you to find out the minimum possible value of the given expression. It is given that x is less than 1. All right. So this particular thing is to be used properly. So given that x is less than 1, we have to minimize the value of the given expression. Now this expression is divided in two parts, the numerator and denominator. I can see that the numerator is a quadratic expression and denominator is a linear expression. I'll not consider them separately. So first of all, I'll try to simplify the given expression. Now from numerator and denominator, you can take 4 common. So after taking 4 common and cancelling it from numerator and denominator, I'll be left with x square minus 2x plus 2 whole divided by 1 minus x. All right. Now considering the numerator, it is a quadratic expression. I will convert it in the form of a perfect square. Okay. So x square minus 2x plus 2 is the original expression. Now to convert it in the perfect square, I'll look at the coefficient of x, which is 2. I'll divide it by 2 and then square it and add and subtract that particular value. So 2 is the coefficient of x. So 2 divided by 2 is 1. 1 square is 1. So I'll add 1 and subtract 1. And the denominator will remain as it is, that is 1 minus x. Okay. Now this term, and this term, this will make a perfect square. So basically x square plus 1 minus 2x. So this will become x minus 1 whole square. So I'll write it as x minus 1 whole square, and then plus 2 and minus 1 will become plus 1 whole divided by 1 minus x. Now x minus 1 whole square can also be written as 1 minus x whole square. Okay, I can say that k square is equal to minus k whole square. Okay, so x minus 1 whole square can be written as 1 minus x whole square. So 1 minus x whole square plus 1 divided by 1 minus x. Now I can separate the denominators. Okay, so numerators को अलग अलग कर लेंगे. So 1 minus x whole square upon 1 minus x will become 1 minus x plus 1 upon 1 minus x. Okay, now consider this expression. I can say that this expression is in the form of k plus 1 upon k. All right, where k is equal to 1 minus x, where also if I look at the value of 1 minus x, since x is less than 1, this is a very important thing. Since x is less than 1, the value of 1 minus x will always be greater than 0. Okay, so 1 minus x will always be a positive value if x is less than 1. X का कोई भी value substitute कर दो which is less than 1, this expression 1 minus x will always be greater than 0. Okay, so I can say that The value of this entire expression is in the form of k plus 1 upon k, where k is a positive number, where k is greater than 0. Okay, so using the concept of maxima minima, you can say that this value will always be greater than or equal to 2. So k plus 1 upon k, where k is positive number, this expression is always greater than or equal to 2. So I can say that the minimum possible value of this expression is equal to 2. All right. And that is the correct answer for question number 1. So 2 is the minimum possible value of the given expression. Let's move on to question number 2.